Just like the graph of sine, the graph of cosine is also periodic. That is, it repeats itself after a certain interval period. Now, this is the graph of y equals cos theta. Here, I drew the graph in the range theta is greater than or equal to minus 180 degrees but less than or equal to 540 degrees. Now, as I said earlier, the graph of cosine repeats itself after a certain interval period. So, if we look at our graph, you can see this graph repeats itself every 360 degree period. So, I'll use this arrow to show this here. As you can see, the graph y equals cos theta crosses the x-axis, in this case theta, at 4 points in this given range of angles. Now, here are the 4 points. Since this is the graph of y equals cos theta, we could say cos theta equals 0 when theta equals minus 90 degrees, 270 degrees and 450 degrees. Remember, there are more values for theta, but here I only showed the values for the range theta is greater than or equal to minus 180 degrees but less than or equal to 540 degrees. Now, this graph has a maximum value of 1 and a minimum value of minus 1. So, the graph y equals cos theta has two maximum points in the range. Theta is greater than or equal to minus 180 degrees but less than or equal to 540 degrees at the coordinates 0 degrees, 1 and 360 degrees, 1. Or we could say cos theta equals 1 when theta equals 0 degrees and when theta equals 360 degrees. And also, the graph y equals cos theta has three minimum points in the range. Theta is greater than or equal to minus 180 degrees but less than or equal to 540 degrees at the coordinates minus 180 degrees, minus 1, 180 degrees, minus 1 and 540 degrees, minus 1. Or we could say cos theta equals minus 1 when theta equals minus 180 degrees, theta equals 180 degrees and when theta equals 540 degrees. So, the common factors of the graph y equals cos theta is that it repeats itself every 360 degree period and crosses the x-axis at minus 90 degrees, 270 degrees, 450 degrees and it goes on like this depending on the range of angles we draw the graph in. And also, another common factor of the graph y equals cos theta is that it has a maximum value of 1 and a minimum value of minus 1. Now let's take this example. Sketch the graph of y equals cos x in the interval x is greater than or equal to 0 degrees but less than or equal to 360 degrees. Now, this is the graph of y equals cos x in this given range of angles. Here, the graph has two maximum points at 0 degrees, 1 and at 360 degrees, 1. So, cos x equals 1 when x equals 0 degrees and when x equals 360 degrees. And also, the graph y equals cos x has a minimum point at the coordinates 180 degrees, minus 1. So, cos x equals minus 1 when x equals 180 degrees. The graph now crosses the x-axis at 90 degrees and 270 degrees. So, y equals 0 or we could say cos x equals 0 when x equals 90 degrees and when x equals 270 degrees. So, as I said in my previous PO Maths video, we can apply transformations to trigonometric functions just like any other graph. So, I've already covered about transforming graphs in my previous PO Maths videos. If you want, check them out for more details. Now, let's take a look at a few examples. Apply the following transformations to the graph of y equals cos x in the interval x is greater than or equal to 0 degrees but less than or equal to 360 degrees. So, now this is the graph of y equals cos x in the interval x is greater than or equal to 0 degrees but less than or equal to 360 degrees. Y equals 1 over 2 cos x. This is the stretch of the graph y equals cos x by a scale factor of 1 over 2 in the y direction. So, all the y coordinates are held and hence this is the graph of y equals 1 over 2 cos x. Since all the y coordinates are held, the graph y equals 1 over 2 cos x now has two maximum points at the coordinates 0 degrees, 1 over 2 and at 360 degrees, 1 over 2 and a minimum point at 180 degrees, minus 1 over 2. The graph y equals 1 over 2 cos x still crosses the x-axis at 90 degrees and 270 degrees just like the original y equals cos x graph. The graph y equals 1 over 2 cos x repeats itself every 360 degree period just like the y equals cos x graph. Now, y equals cos 4x. This is the stretch of the graph y equals cos x by a scale factor of 1 over 4 in the x direction. All the x coordinates are divided by 4, you could say multiplied by 1 over 4 and hence this is the graph of y equals cos 4x. The graph now crosses the x-axis at 22.5 degrees, 67.5 degrees, 112.5 degrees, 157.5 degrees, 202.5 degrees, 247.5 degrees, 292.5 degrees and 337.5 degrees and crosses the y-axis at the coordinates 0 degrees, 1. The graph y equals cos 4x has 5 maximum points at the coordinates 0 degrees, 1, 90 degrees, 1, 180 degrees, 1, 270 degrees, 1 and 360 degrees, 1. And also the graph y equals cos 4x has 4 minimum points at the coordinates 45 degrees, minus 1, 135 degrees, minus 1, 225 degrees, minus 1 and at 315 degrees, minus 1. Y equals cos x plus 30 degrees. This is the translation of the graph y equals cos x by 30 degrees in the direction of the negative x-axis. So, we subtract 30 degrees from all the x coordinates and hence this is the graph of y equals cos x plus 30 degrees. The graph now has a maximum point at 330 degrees, 1 and a minimum point at 150 degrees, minus 1. The graph y equals cos x plus 30 degrees now crosses the x-axis at the coordinates 60 degree, 0 and at 240 degrees, 0. The graph crosses the y-axis when x equals 0. So when x equals 0, y equals cos 30 degrees equals square root 3 over 2. So the graph y equals cos x plus 30 degrees crosses the y-axis at 0 degrees, square root 3 over 2. Y equals 1 over 2 plus cos x. This is the translation of the graph y equals cos x by 1 over 2 units in the direction of the positive y-axis. So we add 1 over 2 to all the y coordinates and hence this is the graph of y equals 1 over 2 plus cos x. The graph now has 2 maximum points at 0 degrees, 3 over 2 and at 360 degrees, 3 over 2. And a minimum point at 180 degrees, minus 1 over 2. Now let's take a look at a few more examples. Apply the following transformations to the graph of y equals cos x in the range x is greater than or equal to minus 180 degrees but less than or equal to 180 degrees. Now this is the graph of y equals cos x in the range x is greater than or equal to minus 180 degrees but less than or equal to 180 degrees. Y equals minus cos x. This is the reflection of the graph y equals cos x in the x-axis. And hence, this is the graph of y equals minus cos x. The graph now has a minimum point at 0 degrees, minus 1 and 2 maximum points at minus 180 degrees, 1 and at 180 degrees, 1. The graph y equals minus cos x still crosses the x-axis at minus 90 degrees and at 90 degrees, just like the original y equals cos x graph. Y equals cos minus x. This is the reflection of the graph y equals cos x in the y-axis. And hence, this is the graph of y equals cos minus x. Since this is the reflection of the graph y equals cos x in the y-axis, it is the same as the graph of y equals cos x. So, the graph of y equals cos minus x has a maximum point at the coordinates 0 degrees, 1 and 2 minimum points at minus 180 degrees, minus 1 and at 180 degrees, minus 1. And crosses the x-axis at the coordinates minus 90 degrees, 0 and at 90 degrees, 0 and the y-axis at 0 degrees, 1.